What up, guys? Thanksgiving Day. Happy Thanksgiving. Pretty cool Thanksgiving video. It's pretty early in the morning. But we are going to try and do probably one or two problems because I got to leave in like an hour. I still got to pack my bag and everything, so going up to Chicago for the day. Sorry, for the rest of the weekend or whatever. But yeah. So let's get into it. Let's do our planet of the day. Let's see, planet of the day. Let's take a look. So we got Hebe, planet Hebe. Looks like it's pretty, another asteroid. I don't know if we're ever going to get planets at this point. Maybe we're going to have to change the list, but that's okay. So test out a little bit. Hebe. Here's our Hebe right here. Very small asteroid. Jeez. 0.5% of the mass of the belt, however, due to its apparently high bulk density, greater than the moon, Hebe does not rank among the top 20 asteroids by volume. Wow. The fifth brightest object in the asteroid belt after Vesta, Ceres, Iris, and Pallas. I think we looked at all of those. Yeah, Ceres, Vesta, Pallas. Ceres, Vesta, Pallas. We haven't looked at Iris. Iris is next on our list. Which will most likely be probably Sunday or maybe Monday. I don't know. Probably Sunday. Yeah, nice. Okay. Well, let's get back to our Leetcode patterns. So we reversed the linked list yesterday. I'm going to do a palindrome linked list. We might only do one problem. We might do two problems. I'm going to aim probably for half an hour video probably. Because I do still have to pack a bunch and clean up my apartment before I go. Just a little clean really quick. But yeah, let's get into it. I don't think I've done this one before. So this should be interesting. Let's have a look at our problem of the day. What is it? It's a hard problem today. Interesting. Minimum obstacle removal to reach corner. Wow, interesting. Can't believe it's Thanksgiving and there's 2,000 people online. 8 o'clock in the morning. It's crazy. Anyway, let's do our palindrome linked list. Palindrome linked list. We have not done it. Now I'm trying to think how we would do this. Can you do an O of 1 time and O of 1 space? Interesting. So I know here we could probably loop through the linked list and add all the values of our thing into an array and then check if it's palindrome. But, does the first value and last value mean it's palindrome? I'm curious. I'm not really too sure. Well, I mean, see, I know I can solve this problem. I know I can just loop through the linked list, add it to an array, reverse the array, and just compare it. compare two arrays. Oh wait, do one in Python. We're just gonna do it. So cur is equal to head, while cur does not equal none. Cur is equal to cur.next. And then at each value, we want to take our value. We want to put it into an array. All right. Declare our array. And array.append cur.val. I think that's how you do it. Let's just print our array. Okay, that's maybe not how you do it. How to access val in linked list icon. Ooh. Let's get some fire music on. Yeah. Yeah. Alright. Okay. Apparently this is meant to be the other way around. Which probably makes sense. But I'm not sure if this is still gonna work. Okay. Okay, let's turn this down a bit because I can't concentrate on this out loud. Okay. See now, I know here that I can just probably reverse the array, so reverse array is equal to and we check if array is equal to reverse array and true, else and false. This is probably a cheating way to do it, but okay. Just want to make sure this actually reverses. Reverse and check properly. Leetcode has logical issue. Reverse array function returns a reverse iterator, not a list. This means that the comparison array will always return false as you're comparing a list with an iterator. Okay. Okay. There you go. There's our problem done. But we're going to optimize the problem. We're going to try and do it in all of one time. Over one space. So now, how would we do this? We've come up with an all one space solution for this problem. It's not trivial, but do you guys think it could be medium difficult? That's an interesting way to do it. Let's try this guy's solution here. Find the mid using a fast and slow pointer. Okay. Let's create our fast. Create our slow. Well, fast is not equal null. And fast.next is not equal null. We want to find our midpoint first, so find midpoint. Let's do slow is equal to slow.next. Fast is equal to fast.next.next. Let's just make sure that syntax is working. Okay. Alright. I think that worked. Okay. So now we want to reverse the first half of the list in line. Compare the two lists over in time, over one space. How would reversing it? I don't understand how doing that would. Okay. So we have our fast pointers here, right? Or at none. So reversing this, turn this into 2, 1. Oh, that's true. Because then you're comparing it and it's the same. But we're separating it into two separate lists, I think. Okay. Interesting. Let's reverse our first half. I don't know how we would reverse our first half. I don't know if we'd have to disconnect our... first half of our list here. Move fast on next on X. Boom, 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 boom. I think we're at this one here. Okay, this is an interesting way to do it. So they kind of reset the nodes. They make cur is equal to head. So they reset it and they do while cur does not equal slow to point to that. I couldn't. That's an interesting way to think about it. I didn't think about that. And then we're pretty much doing the same thing. We're reversing the linked list. So let's see if we can remember from yesterday if we can remember how to do it. I think we should check out another example. Okay. So we have our linked list here, 1, 2, 3, right? We have our cur pointing here, and then our previous pointing here. So this is none. Ooh, none. Okay. It's kind of shitty. So firstly, we want to create a pointer that points here, which is our next pointer, right? So let's do that. So our next is equal, nxt is equal to code.next, right? Our code.next. So now we want to reverse our link. So we want to do code.next. No, actually, I think we want to increase our previous first. So we increase our previous, then reverse our link, I think. Let's do previous is equal to cur. And then cur.next is equal to previous. And then cur is equal to next. That's what I'm thinking. I think that should reverse our linked list. And then we want to compare. Now, how we compare? I guess we compare, since we have our previous node, Jesus, my nose, bro. Oh my gosh. Jeez. Okay. We're on the same show from yesterday, so obviously gotta throw this away in front of anyone. I'm thinking we just compare our... Well, if our previous node is pointing here, right? I think we just compare our previous, and then we compare our... maybe our fast or something. To be honest, I don't even know how to compare two linked lists. I have no idea how to compare both lists. Let's check. Pointer left starts at the head of the reverse first half of the linked list previous. Pointer right starts at the midpoint of the list slow. Okay, so here they... Okay. I just want to do an iterative approach. Iterative approach. Oh, it's telling me that I messed up the reversing. Let's think about what we're doing here. Next is equal to cur.next. Okay. Previous is equal to cur. Cur.next. Maybe it should be the other way around. No. Next, so we got that right. Next is equal to cur.next. They've got cur.next is equal to previous, and then previous is equal to cur. So we've got these two mixed around, but why is that? Handle element, skip the middle element if fast, slow is equal. Okay. So they have left is equal to previous, they make new pointers is equal to slow. And then if was not equal to right. Sorry. I'm so stupid. We need the while loop. While left and right does not equal none. If left does not equal right, return false. Otherwise, left is equal to left.x, right is equal to right.x, and we just return true. Output false, expected true. Slow is equal to slow.next. So this actually compares. Oh. This actually compares. This handles odd length list. Apparently. Skip middle. If fast. Fast is none. Odd list. So I think the reason why we are getting the failed running is because we did mess up this. So apparently, I think this is meant to be the other way around, but I'm not really. I just get so confused with stuff like this. Like, it's reversing. Okay, maybe not. Maybe not. Let's see what's happening here, because I'm not sure. What is wrong with my code? Curious. Okay, so one, if not head, or not head.next, return true. This is if it's empty. It's empty. Let me first find our midpoint. This looks good. Okay, well, comparing the nodes. Fast is not none. The list hasn't. Whoops. Okay. Well, let's see if this is the reason. Okay. Just had a few. Trying to look at this now. So we have none here. Right. Previous, that's okay. Well, next is equal to code on X. We have our next here. Just pointing here. Current.next is equal to previous. Current.next is equal to previous. Previous is equal to cur. Previous is equal to cur. And then our cur is equal to next. Might have to relook at this video, dude. See, I don't understand why we do code.next is equal to previous. All the way back here, pointing to this one. I don't know. I might just have to relook at it later. Let's see if this submits though. So apparently my other solution is faster. I don't know if this is just a bunch of bullshit or whatever, but this is an O of one space complexity and O of n approach. Nice. Okay. Cool. It's time. 8:30. Ooh. Let's do one more. Let's do one more. I can't only do one. I have to do two, at least two. This is an easy problem too, so hopefully we might not do the optimized approach, but maybe we'll remove linked list. Remove linked list elements. Oh geez, given the head of the linked list an integer value, remove all the nodes of the linked list that has node.val is equal to val and return a new head. I haven't done this one. Interesting, interesting. Oh my gosh. What I'm thinking, and see when I see this problem, I'm thinking we use 2 pointers. This one also has fast and slow pointers. Is that we have 2 pointers, right? We have our fast pointer which goes first, and when the fast is equal to the val, then we just get rid of this one and then move the previous pointer equal to this pointer. You know what I'm trying to say? So like, I'm thinking, so we have 1, 2, 6, 3, 4, 5, 6, right? So we loop through with our fast pointer, right? And our fast is going first, right? So we're looping through, right? So our fast is here and our slow is here right now. Our fast is equal to the value that we want to remove. So then we have our previous pointer here, right? And then we have our fast pointer here, right? Or I guess our current or whatever. We remove the node, right? So then this is all gone. And then we change the link of the previous to how fast. And maybe we keep a next pointer here too or something. So then we can do previous is equal to next. And make the link here. Right? Something like that. I think that's the way to do it. And then we keep looping through. Then we might need an edge case here, because then if after is none, then we'll just have to move the link. Dude, this pissed me off, dude. Oh my gosh, dude. Okay. We'll make our current is equal to head. Current is equal to, oh my gosh, dude. Current is equal to head. And we have our previous is equal to none. While cur does not equal none, can we do cur is equal to cur.next. Then we want to check if cur.val equal to val. Then we want to do our logic here. Otherwise, if it's not, we want to prev is equal to prev.next. We're going to increment our slope pointer. And I guess we just were return our head. Now we just want to implement this logic here. Current.val is equal to the val. So it's equal to val. How to remove a value in a linked list. I think maybe how do we actually remove a value in a linked list? Jesus. If cur.val is equal to val, I want to remove the node. Let's see what it says. Current node contains the target value. If previous is none, if the node to remove is the head, update the head to skip the current node. Okay, I understand here. So they're telling me that I need to check if prev is equal to none. So this checks if this is the first node in the list, right? This node here. Then wait, why didn't this is the previous, yeah. Then we want to do now head is equal to cur.next because we're returning head here. So you just want to skip our head one forward. Okay. Else, if this is a normal node in the list, then we just want our prev.next to be equal to cur.next, right? Yeah. Okay. Skip the current node. Okay. We want the else of this one, else here. Then we want to move prev only if no deletion occurs. Previous is equal to cur. And then we want to increment cur. Cur is equal to cur on next. Okay. We got an infinite loop somewhere. Nice. Okay. There we go. We weren't doing anything here because the code on X was inside the if here. So I thought our edge case was here, but really our edge case was here. So I guess we mixed that up. Cur is equal to head, prev is equal to none. While cur does not equal none, so we're looping through. If the value is equal to the value that we're looking for, then we check if previous is equal to none. So this is our first value, and we just put the head up forward. Else, if this is just a normal value in the list, prev.next is equal to cur.next. So instead of our prev.next here, our prev.next is equal to cur.next, so we're changing that link. Else prev is equal to cur, cur is equal to cur.next. So if we don't, this value, if cur.val is equal to val, so if it's not equal, we should prev is equal to cur, then we increment cur.next. Well, can't we do prev is equal to prev.next? I don't know, is that... That's interesting. Why can't we do prev.next instead of prev is equal to cur? Okay, interesting. Why do we get a attribute error when doing this? Interesting. Wait, is it? Preview next. Man, when you ask ChatGPT something, it goes on for fucking forever, man. Like, you know, it can just give like a normal answer, but it has to. Anyway, let's submit that. That was a good problem. I actually like that problem. Cur is equal to head. Well, cur and cur.next. It's not equal null. If cur.next dot val is equal to val, cur.next is equal to cur.next.next. Else cur is equal to cur.next. Return head.next if head and head.val is equal to val, else head. Return head.next if head. That's our edge case. It's another interesting way to do it. Interesting. Okay. Yeah. So, I guess that's our 2 questions. Interesting. Okay. Well, I will see you guys after Thanksgiving. So, thanks for tuning in. For the people that do, yeah. Have a great Thanksgiving.